We are going to be examining trigonometric identities. Trigonometric identities rewards student with a lot of experience in solving trigonometric identities. How do you get experience? Well, really, we have to work really hard on examples. And we will naturally develop an intuition as we solve more and more of these questions. Please ask questions if you're unsure how to proceed. Let's start with the first example from our exercises. Here is a nice trigonometric expression. It's quite complicated. I need to simplify this expression so that it uses as few trigonometric operations as possible. In essence, I just need to simplify this as much as I can. I think the most important factor when looking at trigonometric identities is to take your time and try to think creatively. I ask myself when I'm looking at this, is there any way that I could simplify? So feel free to press pause, take 30 seconds, and ask yourself, do I see a way that I can simplify this? All right, I'm trusting that you hit the pause button and are coming back to life here. What I find curious and what I notice is that the numerator has a factor of tan theta in each term. The denominator has a factor of cotan theta. I ask myself, what would happen if I factored out tan theta in the numerator, cotan theta in the denominator? Wow, that's what it would look like. Now, I factored out a common term in both the numerator and the denominator. That wasn't guaranteed to work, but it certainly looks like it's shaping up well. So I have this expression, tan theta times 1 plus cosine theta in the numerator, divided by cotan theta times 1 plus cosine theta in the denominator. Ask myself, how can I further simplify this? Well, I can cancel out a common factor of 1 plus cosine theta from both the numerator and the denominator, leaving me with a much simpler tan theta over cotan theta. The next step as I would proceed likely would be this one. I'm going to write the definition of tan theta and cotan theta in terms of sine and cosine. Next, I would multiply the reciprocal of the denominator. So what I have left is sine theta divided by cosine theta times sine theta divided by cosine theta. And I feel like I'm in the home stretch here and things should go down quite nicely. This is equal to sine squared theta over cosine squared theta, or sine theta over cosine theta squared, which we are able to recognize as tan squared theta. I hope you enjoyed our first example.